I don't love you anymore. It's a shame. It's darn right shame. All right, let's go over this real quick. Got the 1-inch cubes. Big old neodymium 1-inch. These things are gigantic. I don't think an inch could be that big. Holy cutie. 1 square inch. It's got a lot of tension, a lot of pull power to the core. One thing I want to make a note is that this laminate core is a bunch of different laminates stuck together. I drilled through it and put a screw through it, through this, into the wood to hold this core from going into this magnet. And then this core is also touching this iron, which is the whole fork assembly. And the bolt and the nuts are all iron, steel. And so is the shaft. So is the, yeah? Same one we always use with a 1 on the end. Where was that? So I just want to let you know that on this one, the spokes are steel, the rim is aluminum. This one, the rim is steel as well. I guess, I don't know. I don't know why. Let me come over here. Oh, one more thing. So what makes it easy for me to find out what gauge wire is what, I'm going to set up a nice little spool station up here. And if you look at the number, you can tell the thickness. If you look at the number, you can tell the thickness and on down and on down. So it would be good. What I'm going to do is have a little sample 2-inch wire with a number on a piece of tape. It just with a screw and tied, so I could see the thicknesses and the different gauges. It really helps me because obviously you can see I have ADD, and I'll tell you one thing good about it. There's a lot of different projects here. A whole lot of different projects. So with that being said, and life and family, whatever, with that being said, it helps to kind of just be organized. It rocks my world when I look in here and this place is filthy. And I put everything away, everything has a place, and then I feel good about jumping into stuff. So like when I start leaving little things out, I will get a little flustered, and then I'll come back and I'll put everything away. But let's look at this magnet here. So here you can see it won't stick to the aluminum frame, but it will stick to the, everything I mentioned is iron. So on that one, the frame is aluminum, which is, to me, cool. On this one, the frame is metal, and so is everything else. All right, so let's think about Leedskalnin here. Here you go. You got coil, just like Ed's wheel, with a motor block underneath it. You got all this iron. So raises a lot of questions I have. And the saturation of the iron. Let's think about this. This magnet is strongly coupled to that core. When you pull or push this magnet up or down, the saturation will try to don't like change. So it'll try to follow that, and depends if it's going up or down, it'll either be going this way or this way through the coil. Well, it's also doing it in the iron. So that means this iron, through here, all this iron too, is all kind of, if this is going like this and creating a coming to saturation, then a leaving and a pull, then all this metal is following the path. I'm just going to leave that for food for thought for you guys. Leave your comments. So anyway, you can see that the reason I'm making this video is because, put this magnet back, is because I am getting ready to add some electrostatics to the wheel. What do I mean by electrostatics? I'm talking about 100 to 400,000 volts. Now I'm going to design it by using these guys up here. I'm going to pull them down, and I am going to, these are from an old Wimshurst machine. But what went bad on the Wimshurst machine was the aluminum was on the end. Now I put copper. Copper is the better conductor. So what I'm going to do is I have these brand new. These are what these are, but brand new. And this is just paper on the outside, Lexan. I'm going to cut a hole in the middle of the Lexan and attach it to the framing here. So basically there'll be a washer here that's non-metallic. So that means it'll be a plastic washer of some sort. And then I'll have this go right to the washer. So it won't be touching that wheel, but it'll be fastened to that wheel where I'm gonna somehow tie it to the spoke, and when the wheel turns, it turns with it, okay? With doing that, with the concept is that the pieces will turn, okay? Now what I plan on doing on the back side, like the Wimshurst would have, on the inside here, with some kind of spacer, having the two discs close together, I will have this attached and firm to where it just stays. So that means that the other one that's attached to the wheel will always be moving. And every time one of these approaches another, we'll set up these collectors to where it'll be the same premise, to where the negative side is facing out and the negative part of the coil here pushes the coil away. Well, we're dealing with the negative side versus the positive side. So what I want to do is the same thing with the disc. And by doing so, every time one approaches the other, the one that's fixed, it will go ahead and it will push out. And every time it goes to pass, I'll have a collector on the other side of this one. It'll push out from this one, the one that's moving. It'll push that way because it's either pushing this way or it's pushing that way. So it'll push out particles both ways, and then I'll have them, have them come out and corridor them to two capacitors. So one capacitor becomes one charge and the other capacitor becomes another charge. And from what you do is you tie the two capacitors, the bottoms, tie two of the plates, one plate on this capacitor, one plate on that capacitor. You tie them together, and what you'll have is on the top side, it'll create a two-pole equation. Instead of the two poles being on each capacitor, we're creating each capacitor to be a pole, so we can collect a lot of particles inside each tube that I built. And I think what I'm going to do is use these right here. I've been saving these. These are nice and little. I don't know if I'll start off with that one, but like Tesla says, we're capacitors, that the smaller ones are nice and they're zappy and real touchy and real lot of force, a lot of pressure. And the bigger ones are just they call them lackadaisy, or they're just boof. So you're going to get, when this unloads, it'll be like woof. When this unloads, it'll be like a high pressure. So if you're unloading this, if the wheel's doing, say, 2,000 RPMs, and if you unload this, it's like a little gun going, versus this is going off the same time, but it's going off, boom, boom, but this whole thing is like blasting out. So we'll experiment with that and see what the results are of either or. And this is the reason I'm building this, was for high frequency. I started off with that one and I noticed, okay, well, I do have room to put another magnet in the middle of each one. But I don't think it'll have the RPM and the frequency of what the little guy can do. And then I went ahead and bought these neodymium 1-inch squares, and 2 came in a box, and both boxes were stuck together like there was tape on them, and there was no tape. It was just that the magnets inside the boxes put them together. So in regards to the electrostatic, so I know I can get high voltage going into the 2 capacitors. So what does the wheel do now? Well, we'll get it to where it does multiple things like my ADD brain, and we will experiment with it, and we'll see how it comes into play, and how do we what I would like to teach you guys is how to knock down the high frequency, high pressure, which is what the Tesla coil puts out. When I do my little motor running wirelessly off of this, it's because I have a duplicate coil that's off to the side, and then I come off the top and bottom winding on the other side. But I also wrap it with a thicker gauge wire like a primary, and I knock it down. And you knock it down by using different things, and we'll get into the different things so you guys can experiment, like metal rings, for instance. So these are really good to, these are filters basically, but they're really good to knock down that high voltage. And that's what we'll do in experiments here, and I'll show you guys how having such a high voltage on the side, well, the voltage will be accumulating from there, but it'll be stored in the capacitors, and we'll come out of those capacitors, and what we'll do is we'll knock it down to make it workable energy. And the way to do that is by using those chokes and the filter chokes I'm talking about, and also just electromagnetic induction. We could do some experiments with some test tubes. We'll make a beer bottle and put it under vacuum. We'll put 2 probes on either end, and what we could do from there is we could knock down that high voltage, but we could also choke it electromagnetically, and we can kind of see through a globe plug, we'll call it. We could have another beer bottle that's 1 and not 2 probes, and it would glow connected on one end, and use that as a gauge to see how far we're choking down electricity. And I like with the beer bottle under vacuum with the 2 probes is because we can go by color. And that's something cool that I'll show you guys that I learned, which is by the vacuum pressure. I will show you the different colors. So when I have it under, say, 26 to 28 pounds of negative pressure in the beer bottle or wine bottle, you'll see plasma, purple, bluish purple. And if I go down and let some air in, you'll see it do it to a certain pressure. We're dropping down, equalizing it, and letting more air in the chamber, and you'll start to see like a yellowish orange start to appear, and that yellowish orange pretty much is I guess the frequency stays the same, and I guess you're letting in nitrogen and oxygen and also some organ and 1% of whatever inert ingredient. You're seeing the color from that, but the orange and the white kind of come into play when you're just breaking out a regular color of electricity into the next level up, the next layer. Anyway, I gotta bounce off this phone and get working on this project. Don't know if I'll post it tonight, but I'll try. And stay tuned. I got some more of this copper ribbon. It's pretty self-sticky, and I'll put them on my disc here. I wanted to start brand new. I don't like using old stuff, but I will put that up, mount the other one, have everything spaced out, and we'll try different discs. I got 4 of these discs. We'll try some other ones with some different material, with aluminum, also with bismuth. I also have some, let me see what I got in my goodie thing here. I got some brass. I believe that's tin. No, that's brass. That's brass. That's usable. And then also I got aluminum. I got, that's nothing good. That's copper. This is nickel. Right here is nickel. I think nickel will be a good one to make out of, and aluminum. Did I ever show you guys my little section here? I got bismuth, I got copper connections, I got tin, nickel, quartz crystal, magnesium, silver, gold, copper, clear crystals, graphene, rose crystals, mag glass. And did anybody know that if you take 2 of these quartz crystals, let's end the video like this. Let me see if I could turn the lights off and make any difference. But you rub together 2 quartz crystals, sparks come out. Riddle me that, Batman. Let's go ahead and put the battery on this guy. Get it going. Fill that light. I got my 2 crystals. Let's see if you guys can see any sparks come out of here. Nah. It's gonna have to be a nighttime thing. It's almost like flint, to where you can see sparks coming out. I find that to be pretty exciting. I don't know if you see any sparks. I can't see any. It's too light out. But you do it in the dark. Anyway, you guys, leave your comments. Hopefully you enjoy the vid. Have a great day rolling into the weekend after tomorrow. Tomorrow's TGIF. I'll be hard at it. Having fun. Good hobby to have. Peace out, my bro hands. Leave your comments.